Hey guys, today is our last lesson of the chemistry unit. We're going to be going over essentially what a mole is and how to do some different calculations with it, and then that's it for chemistry. So this lesson is all about the mole, and the mole is just a way that we essentially calculate or count, I should say, different molecules and compounds. So we're gonna, like I said, learn how to actually use the mole. When you have a balanced chemical equation, and we learned in the last lesson how to balance chemical equations, when you have that, the numbers at the front of each compound or molecule, those coefficients, shows us the ratio of different molecules and compounds and atoms in that reaction. But we don't actually know the amount of those different atoms, just their ratio, by looking at those coefficients. So how much there is relative to another one, not the actual amount used. Because atoms are so small, when you're doing a reaction, it would be impossible to count up to however many atoms there are present there. So instead we count them by groups. Just like if you had like a huge facility full of eggs, instead of counting individual eggs, you might just say, okay, 1 dozen, 2 dozen, 3 dozen, 4 dozen, and count them in groups of 12. That's all that a mole is. It's a group, like a dozen is a group of 12, a mole is a group. So it's just the number that we use to count molecules. 1 mole is equal to 6.02 times 10 to the 23 atoms. But again, it's just 1 mole, 2 mole, 3 mole, instead of saying 6.02 times 10 to the 23 times 1 times 2 times 3. That's really all it is. The unit for moles is just mole, but written without the E, so MOL. Molar mass is the mass of 1 mole of an element or of a compound. If you want to know what the molar mass of a lone element is, it's just the atomic mass of that element. If you are figuring out what the molar mass of a compound is, you just combine the atomic masses of all the elements in that compound. So for example, the molar mass of methane would be 12.01 for the carbon, and then 1.01 for the hydrogen, but because there are 4 hydrogens, we multiply that number by 4 when we add it all together. So let's try lithium oxide. Okay, so for lithium oxide's molar mass, we're going to start by finding the atomic mass of lithium on our periodic table. So again, that's just the number at the bottom here, so 6.941. You can certainly round that to 2 decimal places. And then we do need to multiply that by 2 because we have 2 lithium. And then we will add that to just our oxygen. That has an atomic mass of 15.999. We can round that up to 16. And so all we're going to do is solve that. So 6.94 times 2 is 13.88, and we add the 16 to get 29.88. Okay. Once we have the molar mass, we can then calculate the moles of a certain amount of a compound. So moles are measured in the unit mole, MOL. Mass always has to be measured in grams. So if you're given, say, milligrams instead, you do have to convert it to grams. And then molar mass is grams per mole. But I don't really care if you write the units of that. And then this is the formula. Moles equals mass over molar mass. So let's try some practice questions. So the first one says, how many moles are in 58 grams of iron? So iron is Fe. Its molar mass, because it is not a compound, it's just an element, is just going to be its atomic mass on the periodic table. So 55.84. And then moles is equal to mass over molar mass. So I plug in my 58 grams divided by my 55.84. And again, I don't care if you're writing in your units during the formula. I only care if your final answer has its units. And so you should get 1.039-ish moles. Please keep 2 to 3 decimal places when you're doing this. Okay, for the next example, it says, what is the mass of 8 moles of lead? Again, we have to start by finding our molar mass of lead, and because this is just a lone element, we just look on the periodic table and get its atomic mass, which is 207.2. Then we do moles equals mass over molar mass. This time we're given the moles and looking for the mass. So we just multiply by whatever's on the bottom of this fraction to cancel it out. What we do to one side, we must do to the other. So 207.2 times 8 is 1,657.6 grams is our mass. Okay, the last question is ever so slightly trickier, only because this time we are given a compound instead of just a lone element. So we are going to have to take the molar mass of sodium, which is 22.9897. We can round that to 23 because it's essentially 22.999. And then we're going to add the atomic mass of chlorine, which is 35.45. We're not going to round that one because it's not that close to 35 or 36. So we'll just add those together and get 58.45. Once I have that, then again, we do our moles is equal to our mass of 102 grams divided by our molar mass. And get 1.745 moles as your final answer. Okay, one last question that I've written out here. How many milligrams of magnesium nitride are in 0.034 moles? So in this case, because we haven't been given the formula and we have a compound, not just a lone element, our very first step here needs to be to write out the chemical formula. So step 1, write the formula for the compound. So we have magnesium nitride. Because it is ionic, we must cross our charges. So nitrogen has a charge of 3, magnesium has a charge of 2, so we get Mg3N2. Once we have that, then we of course find our molar mass. And so in order to do that, our molar mass is going to be the mass of magnesium, which is 24.3, and then times it by 3, since there are 3 magnesiums. And then add that to the molar mass of nitrogen, which is 14 multiplied by 2, because there are 2 of them. So 24.3 times 2 is 48.6 plus, and then in brackets 14 times 2 gives us a molar mass of 76.6. Our next step is, of course, to use the moles equals mass over molar mass formula. So that was step 1, step 2, step 3. Moles equals mass over molar mass. I'm going to plug in my moles, so 0.034 is equal to my mass over 76.6. Of course, zoom out. In order to isolate the m, we have to multiply by whatever's on the bottom of the fraction and do the same to the other side. That gives us 2.6044 grams as our mass, which would be our final answer, except that it asked for your answer to be in milligrams. So in this case, the last step is to convert grams to milligrams. Now, those of you that don't remember how to do this, if you just write out your King Henry drank whatever during Christmas Mass, in this case, our whatever would be our grams. So King Henry drank Gatorade during Christmas Mass. This would be our milligrams, up here would be kilograms. And so to go from grams to milligrams, we need to move 1, 2, 3 spots to the right. So I'm just going to take my decimal and go 1, 2, 3 spots to the right. Our final answer is 2,604.4 milligrams. Okay, let me know if you have any questions about any of this stuff.